Hello everyone, welcome to another session of thermodynamics. So we have seen the phase change process for a pure substance and we have seen the vapor dome, various property diagrams for water. Today in this session we will be discussing about key terms in the phase change process, the important terms and some example values for water. So as we have discussed in the phase change process, saturation pressure, saturation temperature. So we have seen what is saturated liquid and saturated vapor, as well as saturated liquid line and saturated vapor line. Right. Now saturation pressure is the pressure at which the liquid and vapor phases. So you know that saturation point could be there when the phase change happens from liquid to vapor, right? So saturated level means there is at any point the addition or removal of heat at that point will convert one phase to another. Okay. So for example, saturated vapor phase. Water is situated as saturated vapor phase, let us say. So if you add any amount of heat at that particular point, saturated vapor state, the water will get converted to superheated vapor, completely vaporized. On the other hand, if you remove certain amount of heat at that point, it will convert back to liquid state. So in that regard, saturation pressure and temperature are defined in this manner. So liquid and vapor phases. So there will be both liquid and vapor phases. Any amount of addition or removal of heat could convert back or convert forward the phase change. It will accelerate or decelerate the phase change process. Similarly, saturation temperature is the temperature at which the liquid and vapor phase are in equilibrium at a given pressure. So both are dependent. Temperature as well as pressure are dependent. At a given pressure, when two phases are in equilibrium, that is the saturation temperature. At the given temperature, when two phases are in equilibrium, that is saturation pressure. So these terms are very important when you are using a steam table or a Mollier diagram. When you are dealing with phase change process problems analysis, so you may have to use a steam table or a Mollier chart. So these values, saturation temperature and pressures would be given. For example, if you say the saturation temperature for water is 100 degrees Celsius when the pressure is 1 atmospheric pressure. When the pressure is maintained at 1 atmospheric pressure, the saturation temperature for water is 100 degrees Celsius. I hope with that example it is pretty clear. Now coming to the another important term in phase change process is sensible heat. That is the amount of heat required to raise the temperature of a unit mass of a substance in a process in the same phase. Suppose you want to raise the temperature of water by heating from room temperature, say 27 degrees Celsius to 50 degrees Celsius, only 50. So the amount of heat required for that temperature change delta T is termed as sensible heat. On the other hand, latent heat is the amount of heat required to change the phase of a substance. Likewise, there is latent heat of vaporization as well as latent heat of fusion and latent heat of sublimation. Fusion is the amount of heat in the phase change process of solid to liquid and liquid to solid back. So latent heat of vaporization is from liquid to vapor or backwards. Sublimation directly from solid to vapor. Now this latent heat is also termed as enthalpy of vaporization of enthalpy of fusion, because there is a heat content. Enthalpy, we have studied that it is the heat content or total heat, right? So usually it is denoted by HFG. HFG. F stands for the liquid phase and G stands for the gaseous vapor phase. So enthalpy of vaporization is the amount of energy needed to vaporize a unit mass of a saturated liquid at a given temperature or pressure. That is enthalpy of vaporization. So you may All please note down these important terms as it is very necessary when we are solving the problems. So let us take some example values for water. Latent heat of vaporization for water 2260 kilojoule per kilogram. That means if you give 2260 kilojoules of energy, thermal energy, for 1 kilogram of water, when the water is at 100 degrees Celsius and 1 atmospheric pressure, immediately it will get vaporized completely. Similarly, if you want to melt 1 kilogram of ice at 0 degrees Celsius completely into water, you have to supply 333.55 kilojoules of thermal energy or heat transfer. Now, specific heat for water is the highest of order of the value of 4182 joule per kilogram Kelvin, 4182 joules per kilogram Kelvin, or 4.182 kilojoules per kilogram Kelvin. So you might have noticed the difference in the units. For latent heat it is kilojoule per kilogram, and for specific heat it is kilojoule per or joule per kilogram Kelvin. Could you tell me the reason for that in these units? You may find out the reasons. Just think about it and submit as another assignment. Now we are going to see another important term in the phase change process, the quality or dryness fraction. Quality or dryness fraction for steam. So as we have seen, the phase change process at a constant pressure is a constant pressure line on a TV diagram. The point 3, let us concentrate on point 3, which is a mixture. Liquid vapor mixture is there at this particular point. The average specific volume at any state 3 is given in terms of the important parameter quality or dryness fraction. So we are considering a mixture of saturated liquid and saturated vapor at that particular point. The liquid has a mass of mf. As we know, F stands for liquid and occupies a volume of Vf, total volume. Okay. The vapor has a mass of mg and occupies a volume of Vg. Okay. Liquid and water, it is a mixture. So liquid is having a mass of mf and vapor is having a mass of mv. Similarly, volume is Vf and Vg. Now to establish the location of state 3, we don't know where that location is, how much liquid and how much vapor at that particular point. So if you want to exactly locate this point inside a saturated vapor dome like this, we use this term known as quality or dryness fraction. It is given by lowercase x ratio of mass of saturated vapor to the total mass. That is the mass of liquid plus vapor. So mass of the saturated vapor to the total mass is known as quality. Okay. The value of quality could be in between 0 and 1. It is 0 for saturated liquid and 1 for saturated vapor. So at point 3 in that diagram, obviously the x value will be in between 0 and 1. There is another important term in the analysis of phase change process. You will see this in detail when solving the problem. So please make sure that you understood these concepts clearly before we proceed towards the numerical problems. Thank you for watching, and if you leave your valuable comments in the comment section below, and if you are not subscribed yet, please do subscribe and get learned and share your learning, share your knowledge with your friends and the needy people. Thank you.